Hello friends, welcome back to my channel. Today we are going to solve 16th question from GATE 2022. So we are given an orthonormal basis for a Hilbert space H, and they have defined Fk to be Ek plus 1 where k belongs to natural numbers, and Gj is this sum of minus 1 power n plus 1 en runs from 1 to j, where j belongs to set of natural numbers. Then we have to find value of this expression. What is this expression? It is summation of, this is inner product of gj comma fk and its modulus squared, and the sum runs from k is equal to 1 to infinity. Let's proceed to the solution. To find out the value of this sum, let's first find out the value of this inner product, right? So inner product gjfk, this is equal to, what is gj? This is this summation n runs from 1 to j minus 1 power n plus 1 en comma fk is ek plus 1. Now since inner product is linear, we can write this as summation n runs from 1 to j of minus 1 power n plus 1 en comma ek plus summation n runs from 1 to j minus 1 power n plus 1 en comma ek plus 1, right? Okay, now here j is fixed but k varies from 1 to infinity, right? So there are three cases we will consider for value of k. Those cases are: k is less equal j minus 1, second is k is equal to j, and third is k is strictly greater than j. Let's mark this equation as 1. Also note that ek is an orthonormal basis, so it is an orthonormal set. So EMER, this inner product, is 0 if m is not equal to r, and it's 1 if m is equal to r. Okay, so first case is k is less equal j minus 1, right? So this implies k plus 1 is less equal j. Now consider this first term. Summation n runs from 1 to j minus 1 power n plus 1 en comma ek. Now basically this is this alternating sum en comma e1 comma ek minus e2 comma ek plus and so on, plus last term is minus 1 power j plus 1 inner product ek, inner product ej ek, right? Note that since k is less equal j minus 1, all other terms will be 0 except the one for which this n is equal to k. So this will be equal to minus 1 power k plus 1 ek, right? All other terms will be 0. Why? Because en ek is orthonormal set, so this will follow. The inner product will be 0 if the indices are not equal, and it will be 1 whenever indices are equal. So all other terms will be 0. All other inner products will be 0 for which n is not equal to k, and only that term will remain for which n is equal to k, and there is some n between 1 and j which is equal to k because of this condition. Since k is less equal j minus 1, there is some n which is less greater than 1 and less than j for which n is equal to k. So first term is this, and this is equal to minus 1 power k plus 1, right? Similarly for second term, note that Now we have the second term of inner product is ek plus 1, and k plus 1 is less equal g. So this means that there is some n, there is some n belongs to 1 to j such that n is equal to k plus 1. This follows because of this condition, right? So that's why in the second term only that term will be non-zero for which n is equal to k plus 1. All other inner products will be 0, right? So the second term, if we expand it, we get the same thing, except that in place of k there is k plus 1, right? This will be this. So that term will remain for which n is equal to k plus 1. And what will be that term? It will be minus 1 power k plus 1 plus 1, comma ek plus 1 ek plus 1. Now this inner product is 1. So this becomes minus 1 power k plus 2. Okay, now adding these two terms, we get, therefore, GJFK inner product is equal to minus 1 power k plus 1 plus minus 1 power k plus 2, and this is basically 0, right? So we got, if k is less equal j minus 1, then this inner product is 0, right? Okay, now second term is k is equal to j. Okay, so if k is equal to j, then k plus 1 is equal to j plus 1, which is strictly greater than j. So in this second term will be 0 because all inner products will be 0, because k plus 1 is strictly greater than j, right? Whereas in first term only the last term will be non-zero, only the last inner product, that is for n is equal to j. So GJFK in this case, this is equal to minus 1 power j plus 1, comma, oh sorry, this will be minus 1 power k plus 1 ek. This is equal to minus 1 power k plus 1, right? So for k is equal to j, this is our inner product. Now third case is k is strictly greater than j. Now if k is strictly greater than j, then all inner products will be 0, because none of the n will be equal to k or k plus 1, because k is strictly greater than j. So k plus 1 will be also strictly greater than j. So that's why this becomes 0 for k is strictly greater than j, right? Okay, now these are the three cases for values of k, right? So adding all these cases, okay, now the summation is not of the inner product, it is summation of modular of inner product, and we have to square it, right? So for all k less equal j minus 1, the inner product is 0. Only for k is equal to j, it is non-zero, and for k is greater than j as well, it is gz comma fk. This is 0. So therefore summation k runs from 1 to infinity modulus of inner product of gjfk squared. This will be modulus of minus 1 power k plus 1 squared. Okay, now k runs from 1 to, okay, so second case is k is equal to j. So here k varies, so Let's just make j here because k is varying and j is fixed. The answer will not change here, but just for the sake of how we have defined the variables. So this will be j plus 1 squared. Now minus 1 power j plus 1 modulus of that thing is 1 and 1 squared is 1. So the value of this that given sum is 1, right? So that is option D, hence D is the correct option. So I hope you all understood this solution. See you in the next video. Thank you.